Now, what is a black body in thermodynamics? Okay, so we are not talking about any black colored object here. We are specifically talking about the thermodynamic black body. So what do we mean when we say that what is the condition for some body, some object to become a black body? So at this point, if you have taken the classes on Doris tutor, we should all know that when electromagnetic radiation is thrown at an object, it would absorb certain amount of radiation. It might not absorb all of it. Some amount of radiation it might throw back or throw back to us, and that is what we are actually seeing. It will reflected radiation, that is the color of the object that we are actually perceiving. Okay, a black body is such an object which actually absorbs. Okay, so it does not throw back or it does not reflect any radiation. It actually absorbs all the radiation which is thrown at it, no matter what the angle of incidence is, no matter what the frequency of the radiation is. A black body would absorb all the radiation which we are actually shining on it, which we are actually throwing at it. So that is the definition of black body. Now the black body as defined, it is defined only in terms of the absorption. It is characteristic of the absorption. Okay, but the emission of the radiation from the black body has a special meaning. Okay, so note that we are defining the black body in terms of absorption. That is what happens when I shine light on a black body, right? So for example, this is an example of a black body, and the radiation, it is entering this particular black body, and all the radiation which is entering, no matter what is the frequency of the radiation, no matter what the wavelength is or what the angle of incidence is, all the radiation which is thrown at this black body, it will all be absorbed. Okay, but this is about the absorption. So we are defining the black body in terms of absorption, the properties of absorption. But on the other hand, the emission of the radiation from the black body has spatial significance. Now when this absorption of the radiation happens, at a certain point, the black body, you can think of it in this way, will be full with radiation. So it will have so much radiation that slowly and gradually this radiation would start escaping. Okay, and it would start throwing out radiation. Okay, and this is the place where it has reached a point of equilibrium. Okay, so this is the way of thinking about it. It has some special meaning in quantum mechanics. We can this phenomena has a special name, but the way to think about it, you are throwing all the radiation into the black body. At some point in time, this black body will be filled up with radiation, and then it will start emitting radiation, and this means that it has now reached a point of equilibrium. All the radiation which is thrown at it, it absorbs. That radiation is not reflecting back, it is absorbing that radiation which is actually shining on it, but at the same time it is also throwing out, or it is also emitting the same amount of energy as it is absorbing in the form of radiation only, and that particular radiation is known as black body radiation, and it happens only in equilibrium. See, when we are talking about the emission of radiation, of black body radiation, we are talking about the black body having reached a condition of equilibrium in which its temperature is no longer increasing. So it is residing, it is staying at the same temperature, and then it is started emitting this radiation. See, the property of the radiation, black body radiation, or this emission from the black body, is that it depends only on the temperature of the black body. At a particular temperature, the radiation characteristic would be particular, irrespective of the shape of the black body. At a particular temperature, a particular kind of radiation characteristic the black body radiation would have, or the black body emission from the black body would have, and this is what is shown here. The diagrams that we are all seeing it are known as Planck's law. Okay, so these graphs are known as Planck's law, and they are actually nothing but black body radiation, this characteristic curve of black body radiation, that if this was the temperature, then this is the radiation profile of the black body radiation. If for temperature were 4000 Kelvin, then the green line, 5000 Kelvin, the this particular blue line. Okay, so this is the characteristic black body radiation. Okay, so now we have understood that the black body radiation has a specific significance. Now the third thing about black body is that it is a diffuse emitter. What does it mean by diffuse emitter? It means that if I were to measure the radiation emitted from the black body anywhere around it, I would find in the perpendicular direction, if I were to measure it, I would find that it is the same all around. Okay, so that is what is meant by the diffuse emitter. It does not mean that all the energy is thrown out in a particular direction. That is what it means. It means that if I were to measure the energy being emitted all around the black body in the perpendicular direction, then it would turn out to be the same per unit area all around the black body. Okay, so this is the third property, diffuse emitter. So what are the three properties again? It will absorb all the radiation. Then when it has reached the point of equilibrium, it will emit the radiation, and that particular emission, that is known as black body radiation, would have a specific frequency profile. Okay, and that is what is shown here. That particular profile depends only upon the temperature of the black body. It does not depend upon anything else, no matter where you place it, whether it's in space or not, or what the shape of that particular black body is. That is the second property. And the third important property is that it is a diffused emitter. Okay, so those are the three important properties of the black body. Now, in the next class, we will talk about the emissivity. What is the emissivity and how does it relate to the black body, and how can we talk about other bodies in terms of the emissivity of the black body, and where does this particular black body radiation. So this is a theoretical phenomenon. It's very hard to practically construct black body. So where does the application of this theoretical phenomena come into play? So subscribe to our lectures on Doorstep Tutor, where we have discussed all of these things in great detail to tackle any kind of problems you might have to solve. Thank you.